Welcome, everybody, to the American Space Museum. I'm Marquette, and we're so glad you're with us to stay curious, talking with Mikey Haddad here with me. Mikey, how you doing, buddy?
Very good, Mark. How you been?
I'm great. I'm great. Tell everybody how many years you worked at NASA and what level 4 engineer means.
Okay, yeah, we basically I was there 32 years. Actually started as a co-op in '79, and was STS1 as a co-op student, still in college.
Really?
And then graduated in '82.
What college?
University of Central Florida.
All right.
It was actually FTU at the time. Those people remember it back then. Florida Technological University in Orlando. And it started in '82, graduated full-time engineering, and went in directly into level 4. And level 4, again, what that is it was an organization kind of unique where NASA actually performed the work that a contractor normally would. Kind of the way it works out there is you have contractors that do the physical hands-on, push the buttons, turn the bolts, torque the fittings, those kind of things. And then NASA basically is like one step back, very important, but it's actually the contract does the physical work. Where in our organization, we as NASA did that function.
You just didn't have the clipboard checking as somebody else turned that.
Right. We were right there. We had contractor technicians was all. We had NASA engineering, which is what we did, NASA quality, NASA safety, NASA operations. All that was done by NASA, which is normally done by contractors. That was what kind of level 4 was about. Very, very fun, very unique. Play with the hardware myself.
Roman numeral 4, IV, which I thought was like when you're going to be level 5, you have to go to another test or certification. He goes, no, you got a big, gigantic building there.
Right.
And it's segmented into different levels of degrees of payload processing.
Yes, sir.
What's that big building called?
It's called the Operations and Checkout Building. Now it's the Neil Armstrong Operations and Checkout Building.
Is that the building where we see the astronauts on the walkout go into the
Vastro van? Yes, they're on the 3rd floor there. That's where the astronaut crew quarters is in the Operations and Checkout Building.
Okay.
And where you see them come out of the doors or double doors, it's actually, there's like a cul-de-sac. There's like 2 main sections, and that was a cul-de-sac where the crew comes out, and they've been there since
so that was your
Apollo and all those.
The payload processing there.
Yep, that was where we did all the work.
I remember as a tourist 30 years ago, you could look out windows and look down and see people working on stuff there. About how many people on an average day were working in the ONC operations and checkout?
Hundreds in the building itself, multiple hundreds, probably over 100 in the high bay, the clean room area where the flight hardware was, because you had the main high bay, low bay areas, and then you had the office areas and laboratories that made up the ONC as well.
Kind of in a automotive type factory sequence of events.
Yeah. Yep. It was kind of build up.
And the Henry
assembly line.
The
assembly line. Yeah.
Assembly line.
Yep.
Yes.
That was kind of what it was like. Okay. And so we were kind of in the starting point with the nuts and bolts kind of.
We'll see some pictures of some of those areas in there. Yep. And Mikey, you grew up where?
Actually, was born in Cleveland, Ohio. Go Brown.
You hear that? Go Brown.
But moved to Florida. I was only 9 years old. And so basically been down there since I was 9 years old.
You still keep Ohio roots?
Oh, yes. All the relatives are still up there. Actually, was up there in August for a nephew's wedding.
Oh, cool.
So, up that area.
I'm very familiar with the Mogadore-Akron area.
Yep.
And I grew up in Findlay on the other side of the state up there, not too far from where Wapakoneta is, Neil Armstrong's hometown. But I love that area, southern, a lot of Amish people over there in the middle part of the eastern part of state by Akron, all that stuff. So we're talking space here. Mikey, we're glad that you're with us today. You've been with us for a year, brother.
I can't believe that. Wow.
We're so happy that you found us.
Thank you. Thank you for letting me do this. This is awesome.
We're privileged to tout the shuttle era people with this platform and have great people on here like you. Our audience learns so much about the shuttle era that though it's 12 years past, it's still fresh in our minds with the orbiting International Space Station going on.
Yes, sir. Yep.
So, thanks, Marty. We're going to have our auction October 7th, online only. We have Woody Springs collection on there. Astronaut that was early, got caught up in the shuttle Challenger disaster. He would have flown again. Yep. There's Robbins flown medallions. Those are the most cherished flown medals of all. They go from $500 to $5,000, some of them. There's some flags that were on the surface of the moon, Mikey,
Sweet.
in this. There is the first Snoopy Award ever given to a man named Kingsley, who was a test Apollo astronaut for Grumman.
Oh, wow.
And his Snoopy wasn't flown, but it's still the first one and may fetch $10,000, our collection analyst says. Did you ever get the Snoopy recommendation?
I did receive the Silver Snoopy Award for my work on Space Station. A lot of the EVA activities, we would do dry runs and checks and fit checks on the ground with that before they would fly to make sure there wasn't any problems. And so the crew gave me a Silver Snoopy because we did find a lot of problems on the ground we fixed. That if it would have happened in orbit, would have been a real problem. And so that's how I got my Silver Snoopy Award, was EVA Ops on Space Station.
I guess you call it the biggest attaboy out of the NASA industry of congratulating you for a job well done.
To me, that is the best award. Nothing against all the other awards.
Right.
Okay. But personally, for me, the Silver Snoopy was my best. Yeah.
Just
that's
a small little Snoopy went to space. We've talked about it many, many times on there, so that's why we bring it up. We are going to have a fundraiser in about a month, kick off our constellation, our galaxy of giving, create a constellation out of your donations. There's the QR code to donate to our nonprofit at any time. And everyone coming out of all nonprofits coming out of this COVID pandemic and now the high inflation going on are up in their fundraising games. And we've not been very aggressive about it. But we need to be, and so we appreciate people, whatever they can give us, we will put it to great use here. Mikey, you've been around our museum here. How would you characterize, for someone that's not been in the American Space Museum, what the experience is like?
You just need to come and see it. It's one of those places where when you walk in the door, it'll hit you right in the face right off, and as you go through this place, it is a museum of space. You guys have done such an awesome job here on all the things you've got. Some of the stuff on the walls is just unbelievable. The stuff you guys got here, and all the history behind it all. If you got any interest in the space program, you've got to come see this American Space Museum in Titusville, Florida, because it is just packed with all kind of fun stuff, things that you would probably never ever see anywhere else on the planet, from what I'm guessing. Some of the things you've got here is just amazing.
Well, there's our public service announcement for the year, Marty. Thank you very much, Mikey. It is a passionate place. That's why I'm here. I came as a tourist, put my $8 senior citizen discount money down, and then knew when I left here that somehow I would be involved in this museum. And thanks to our staff here, led by Karan, Conklin, executive director, you mentioned the wonderful looking exhibits. Nick Enix is our collection manager that's taking it really seriously. He's also a Boeing retiree, worked in the ONC with a laser machine around there so far.
Yeah, it's very organized. You guys got it well organized here.
Well, thank you. It shows that. Marty, we hadn't said hi to you officially on our UCX family microphone there. What, you got a comment or question?
I got a comment. Mikey mentioned that as soon as you walk in the door, well, when you first walk in the door, you see the Cole Stotts sign, if you will, "Welcome Earthlings."
Yeah. There's a welcome. Yeah, thank you.
It's so neat. It is really neat.
We're thinking of Earthlings. I wonder if people are wondering, what in the hell are we tripping on here? Look at all this green screen back here there.
Yep.
This is part of our program today.
Yep.
Tell us what this is, Mikey.
This is actually a picture of a volcano in Russia, and I'm not going to try to pronounce the name. Actually, when STS-68 lifted off, this is the volcano that erupted the day that they lifted off. And they actually imaged it. This is a radar image of that volcano from the STS-68 mission. And again, all the colors are basically mean something. I'm not going to get into what all the colors are, but I could talk about that when we actually get to the images part of the talk. But that's basically what this is. It's one of the images from the STS-68 mission.
And that's what we're talking about today, the Space Lab radar missions, the shuttles of September. STS-68 is the last mission of the month there.
Mm-hmm.
Marty, it's got 3 astronauts who we've enjoyed, that we've met, who we really enjoy. Thank you, Mikey.
Mm-hmm.
Mike Baker was the commander. We're going to look at that right here. There you go. There's the 2. Now, we've got the other SRL-1. Tell us about, did they fly? When did that SRL-1 fly?
That flew, in April?
In April.
That was April, and then the other one flew in September, both of 1994.
And this is a space radar lab. This is one of the coolest visually deals that was in the whole program.
At that time, and it's led to so much advances in and Earth radar, Earth observation systems. It's just, this is the precursor for just wonderful things that have occurred.
30 years ago.
Yep.
All right, 1994, basically 30 years ago. It discovered, Mikey's going to tell us all kinds of things it discovered on our Earth. But there's the radar lab, of course. We had Mike Baker on the show. Mike has done the commander. This is his first command, his second of a third of 3 flights for Mike there. We'll see the crew here in a minute. We'll look at that next there. There's the SRL-1 crew in April, includes Tom Jones there, who we interviewed on Stay Curious about a month ago. He's on the left. The lady is Linda Godwin. All right, above Linda is Kevin Chilton, the pilot, is up there at the top. Commander Sid Gutierrez is on the right. And then you've got seated there is Michael Clifford and Jay Apps. I was just looking at Jay Apps' photo book last night. It's really crazy. It's called Orbit on there.
I haven't seen that.
So the other crew repeats with Tom Jones, who did both of these. He talks on our program that you can see on YouTube about he did a lot of photography on this mission, looking out the windows all the time, running that radar. There we've got Bakes up at top, Mike Baker. This is his third of 4 flights, his first command. Then we have Terry Wilcutt. We've met him several times. This is Terry's first flight of 4. And down to the right is Daniel Bursch. And Daniel Bursch has got 2 of 3. Steve Smith, there's the mustache. Doesn't have a mustache anymore when you see him at the astronaut encounter. This was his first flight of 4. And then you have seated there Peter Wissoff, and then Tom Jones there in the outer right there. So we asked Bakes about steering it and moving things around like that. And his attitude was, hey, I'm a pilot. That's what we love to do. It was fun to maneuver it around there. So you're going to tell us all about that starting now, buddy.
Okay, yeah, this is basically a configuration of both missions. As you can tell from the graphic, the SIR-C and the XR, which is Spaceborne Imaging Radar, and then the Synthetic Aperture Radar, SAR. You can see it's huge. It takes up almost the whole cargo bay of the orbiter. And then there's the MAPS, which is basically an atmospheric experiment. They've flown an MPES in the front. So this is huge. Okay, this is kind of a close-up of the antenna. There's actually 3 different antennas on here. You see kind of on the top left, you got XR, which is basically an X-band, which is around 10 gigahertz. That's movable. That one actually could steer. You can actually rotate. They can move that, physically move that. Then you had the L-band and C-band antennas that were kind of fixed. What was interesting about those is they could electronically aim those, which is kind of neat. And what that does for them is one of the things they did on these missions was you could take an image and then take an image just slightly offset, and then you run through basically interferometry and you basically create a 3D image. It's almost like the red and blue glasses you got, same kind of thing. And so this is basically the detail of those huge antennas that flew on the back in the cargo bay and in some of the other electronics. It actually was mounted to 2 pallets. Space Lab pallets. That's kind of, married to the pallets. This is kind of how we were involved in prepping the pallets. The antenna, the structure knot was built. The XR was actually from Germany and the Italians. And then basically the structure was all done at JPL. And then one of the things about this antenna was, of course, it radiates in different bands, very dangerous. Well, how do you test something like that? The operations checkout building is a non-hazardous building, which means we can't do that kind of work. And so people, Riley, Dern, and Rich Johas, who is basically the engineers who worked on this from level 4, they flew to JPL, where they're able to set this up in a building and actually radiate at full power.
They took the hardware that
Right.
we're going to see some pictures of in the ONC. Actually took the hardware to Jet Propulsion Lab.
Well, that's what was being worked on, and our guys flew out there.
Oh, okay.
Okay, and what the idea of that was to learn about the experiment, learn about how things worked. So when it came to Kennedy, the procedures were all ready. They understood the experiments. We did that for almost all the missions. We'd fly anywhere in the world to where the hardware was being prepped before it got to Kennedy to learn about it and understand and basically get real familiar with it. Because at Kennedy, of course, we had the ground support equipment. Then when simulate the orbiter and all, we test against the flight hardware.
With astronauts too?
With astronauts, exactly. Oh yeah, that was kind of the fun thing was when this hardware got to Kennedy, and we started a lot of the testing. And this is stuff the crew's going to do on orbit. This is basically dry runs of what their actual operations are on orbit, the real flight hardware. And so the crew would always usually try to be there when we're doing testing, because that's exactly what's going to happen on orbit. Okay, and so that was basically, I just wanted to show kind of the details of what there's actually 3 antennas on there. Okay, this is kind of what the mission was like. The orbiter faced the Earth, and it would go over. You can see kind of on the bottom of the ground track of the shuttle, and then how the image is taken. Let's take like a swath, like across the surface of the Earth, and that was basically how they would take images, and then that would be relayed through a teacher satellite back down to the ground.
10 to it looks like from 10 miles to about 6-7 mile swath there.
Yeah, that's about how wide each kind of the. So it would take that over the course of how many ever days the missions were, and that occurred for both flights, 59 and STS 68.
And they were up there 11 days over a week, about a week and a half. You see the TDRS there, everybody. The TDRS Tracking Data Relay Satellite. These are the important satellites for NASA communicating with its International Space Station and other things.
Yeah, they had. They said they had equivalent to 20,000 encyclopedia volumes.
Really?
70 million square kilometers of Earth was imaged during this. Okay, this shows you how what kind of everybody involved in this flight. And it just wasn't one little spot or one little country. It was all these different groups from throughout the world, and you could see up at the top there, where it talks about the number of principal, 49. Investigators. The different countries involved, primary observations that were done. I mean, it was a huge effort because, of course, it related to the whole world. These missions basically imaged as much as about 12% of the entire world, about 25% of the land was imaged through this mission. So that was definitely an international effort. Yeah.
Now you got some paperwork here, of course.
Okay. Now what this is basically, again, when we were doing work on this, the hardware itself required cooling. Well, this is a TPS, basically a problem report that showed where we were getting leaks. The system was leaking. Okay, and so we had that happens a lot of times. I had to do that myself a lot of times. Well, the reason I wanted to show this was if you look down at where it's the disposition, which is the lower section, that basically tells you what's the results. Okay, we tried to fix it and we couldn't. And so this is an indication where we actually had to go waive a couple of requirements. We could not physically fix everything, and that happens sometimes. We try our hardest. The good thing about that was the leak rates were within acceptable. It wasn't a large leak rate. It was close to being in spec, but it still missed the spec, and so we were able to waive it. So this is one of those fortunate times where actually we were able to waive the spec and say we can fly as is, even though it's leaking a little more than we want to. It's okay to fly, and that's what I wanted to show. This is to show I wanted to let everybody know that everything's perfect and everything was always fixable. Sometimes we couldn't do that. We had to waive.
What was leaking? And
it was basically the cooling loop. What we do on
would it evaporate or cool up somewhere?
It would just evaporate, yeah.
Okay.
And so,
that's why you okayed it then.
But of course, what happened is it leaked out. Then you had less fluid in the coolant system. Well, of course, if it leaks out too much, now you don't have cooling, and you start to burn things up. Luckily, these rates were so low that it would have been fine, even over a course of an extended mission. We would have been fine. But that was kind of the idea here, was to show, hey, everything's not perfect.
That's interesting.
And then this next one is really interesting.
Yeah, okay.
Okay, you see there in the middle there, it says tornado.
Yeah, reason.
Okay.
Tornado, exclamation point.
When we wrote our procedures, okay, we always had what's called an Appendix Z, and that was an emergency shutdown. We could be in the middle of testing and something happens. There's a fire, something like this. There's a tornado, and you have to either pull the plug and just run, or you can orderly shut it down. Well, it's what we call Appendix Z. Well, in this case, Roland, a sheriff who was working on this mission at the time, there's a tornado in the area, and we had to power down. This was the MAPS experiment. He had to go through an emergency power down, which is the only time he said in his career he ever ran Appendix Z, which was an emergency shutdown. And this is basically the paperwork to basically bring it back up, because you can be, some of these procedures are hundreds of steps, and there's no way of knowing where in there you can have to be called to say, hey, we need to go ahead and shut things down. And so basically this is basically a deed, temporary deed that says, hey, now this is the part of the sequence we were in when we had to leave, basically power things down because there's a tornado in the area. And so this is a deed basically to pick up where he left off, to go back in. And it was temporary because hopefully this never happens again. That's why we call them a temporary deviation. But I wanted to show that, we had to worry about stuff like this. And it was called Appendix Z, and every procedure had one of those in case there was some reason we needed to do an emergency power down.
Signed and all that stuff.
Oh, yeah, all the signatures. And
Was that in triplicate or something, probably?
well, at the time when we first started, it was still carbon paper.
Yeah.
And we had to do everything by hand. Later on, of course, you had computers, but for years we had to do the computer. Yeah, so we had to basically had the carbon paper, and this is, you can see, all done by hand, all handwritten. It's not on a typewriter, all done by hand. Yeah.
I think only Tom Usiak knows what carbon paper is out there. What do you think, Gary? You actually had the carbon sheets between paper that would imprint down. Sometimes you had 2 or 3 layers of it on there. You've all seen that stuff in bills and so forth. So now we're looking at the real stuff here with Mikey Haddad telling us about this amazing radar system that we flew twice in 1994, 6 months apart. And behind us here is one of the incredible images. There's books out there about this. We don't have a whole lot of images, but Mikey's going to tease us with some of the discoveries.
Yeah, I won't be able to get into too much detail with science because, to tell you the truth, I'm not an expert on it, and I don't want to butcher it. But you can basically go out there and read about this amazing stuff that happened during these flights. Okay, this is a picture showing that the antenna being installed on the pallets. The pallets are the U-shaped structures on the bottom underneath it. And again, that's kind of, the work we kind of did before the antenna got there, was getting all this hardware ready for the two to come together. And so it's a picture of a large antenna structure going on in the pallets in the operations and checkout building. Again, there in the southern end of Kennedy Space Center. Now, one thing, too, I wanted to bring up was there was another gentleman, and Brad, I'm not going to do your middle name because I'll butcher it. So it's Brad Moore who sent me some information about, again, with this, we had to worry about the flight hardware, but we always had to worry about the ground support equipment. The GSA was used to support all this stuff. Okay, well, Brad was one of those guys that worked what's called in a partial payload checkout unit, PPCU, that was used to check out all this hardware, getting ready for flight. We tell stories about how you had to configure with cabling, software, all that for each mission uniquely. Okay, and so for this mission, again, he had to go through all kind of things. I'll just read it real quick. He said there were different PPU configurations for each mission, but only had a single checkout system to support different payloads in the low bay. Stands had physical cable, had to be connected, disconnected, either at the test stand or at various patch panels. Okay, which payloads connected was able to be tested, determine the experiment integration critical path for that mission. So the one that was basically up would be the one they'd test. And he says there was time when we had configured 3 different payloads within a month. He said during the course of processing there would be revisions. They had software would come in and it wouldn't work. And so they had to do revisions to the software, payload data. He says on the PPU side, in addition to the database subsystems, there are application processors, desk-sized silicon graphics computers, and 2 types of display processors. The graphics silicon workstations, they were nice ones. DEC Unix workstations, and all the PPU computers ran some variation of Unix. Well, also they had displays. They had to create unique displays. So our guys not only had to know about the flight hardware, how the flight hardware worked, they needed to understand how the ground support equipment worked, the software that was used on it. They had to build their own displays at times to be able to see things that normally you would need you'd see during the mission. This is to test it all out. So there's a lot of things that happen on our area that really didn't have to worry about during the mission because our job was to test all that. And so that's kind of some of the stuff he talked about. He talked about the C application code C or C++, he couldn't remember what kind, that allowed them for predefined commands and text inputs. And there's a formal process for validating all that. Again, we wouldn't connect up this ground support equipment to flight hardware unless it was working. You don't want to connect a piece of GSE and destroy a $10, $20 million, $30 million piece of flight hardware.
Right, yeah.
So it was their job, Brad and those guys, to make sure that whatever got connected was ready for the testing and connections. That was an amazing work.
Flipping
and
the
Brad,
script,
you're out there
to make you hold your breath there when you're...
Well, and that's what they did. And they had the guts, and that was their job to make sure, hey, is this ready to go? Yes, it's ready to go. Let's cable up. Let's power up. Let's test this bad boy. And that was their job. It was amazing. And so, Brad, if you're out there, I know there's a lot more to it than that.
I try to effort him. Hope he watches this. We know Maynette's watching here today. And
yep.
Shout out to some of your other friends out there. Maybe
okay.
Louis Delgado's watching.
Maybe, yep. Yeah, some of the Level 4 gang.
And hey, did Houston ever say, hey, we got a call from an astronaut? Tom Jones says, the switch don't work.
Oh, sure.
Or something like
Oh,
that.
sure. Oh, yeah.
And to get Mikey, that's not working like he told me it would when we were.
That's a real good question. And to answer your question is yes. And a lot of times because we were real familiar with the hardware, we knew it like the back of our hands. We spent sometime years with this hardware. We would support the flight for that exact reason. Okay. Something happens during the mission. Hey, they power this up, or this has been powered up for 8 hours. And all of a sudden, boom, this thing happened. And all of a sudden it shut down. Well, what was happening when it shut down? Oh, okay, we saw that when we were doing our testing on the ground, or we knew, okay, we understand that system well enough to us, this must have caused that to shut down.
Okay.
And so a lot of times our guys would go to Marshall, which is where the Payload Operations Control Center was, or to JSC to support the flight for that exact reason. They knew this hardware. If a problem came up, I know what the problem is. I know the solution. The other thing too, which is a good thing you said, was because we worked with the crew, they knew us. When you said Mikey Haddad, I worked with Mikey for the last 8 months. Scott Vongen, Rich, Brad, all those guys, Riley Duran. So as soon as he says, well, Riley thinks it's this. They said, I worked for Riley for the last 8 months. Okay, Riley says it's working. Yeah. That's what cool. We're going to do. And so it was cool because that's how we worked. We got so familiar with each other that they trusted us. We trusted them, and because of those reasons, that happened many times where things would go bad on orbit, and it would be something we saw on the ground. And it was a very quick fix because they're on a timeline. You can't spend 12 hours trying to figure out what's wrong. You need to solve it now so they continue on with their science. So that would happen a lot of times, and that's why our guys supported the flights.
Think of that level of training, Marty, that the astronauts have. Add that layer there where the experiments you're doing. You've got to know, Mikey and Scott and Brad and all these people on there and trust that their information is going to be right.
It's going to be right.
Because they've worked with you on there.
Yep.
Very interesting here. We got a couple other pictures.
That picture there, I wanted to show that one. That one is very interesting. That's basically 3 different missions, all in the Lone Sea High Bay Level 4 area, all at the same time. One of the things
there's the radar.
The radar's on the right there. You say it's his big JPL. That's the Sur-Sea radar. That's basically the mission. The one that's hanging from the crane is the LIDAR in space telescope, and the one below it is the Astro payload, which is STS 35 and 67. Now, one cardinal rule was you never lift overflight hardware. Okay, you see, it's just something we wrote in the procedures. You did not want to lift anything over flight hardware in case something happened. Well, in this case, there's so much stuff there, and that's the reason I wanted to show this picture. We had so much going on that there was no way to avoid us moving this hardware around without going over some flight hardware because there's so much of it in the high bay at the time.
Wow.
Yeah, so it's that's why I wanted to show
this. This is the 1990s, folks, the wheelhouse of all this science transitioning to the space station.
Yep.
That's your telescope there on the bottom, huh? That you're restoring, correct?
Yep. Yeah, the one on the bottom left there, that's the Astro telescope package. That's what we're restoring in Huntsville right now. So,
Marty's got a question.
Yes, sir.
Yeah, why could that not be stored in the low bay?
That is the low bay area. That's all the level 4 low bay area, the operations and checkout building. That's in the west end of the low bay. That's basically our level 4 area.
And why could it not be stored in the high bay?
Well, as you go down, as you went down the building, there was all other hardware that was in there from other missions, either going out the door or coming back. So we had to do both. We had the integration and de-integration. So the rest of the building was basically full as well. But again, these were here because this is the area we were tested in for level 4. So we had to figure out how to put all this hardware in there. Now, to answer your question, Marty, there were times where we did that, where we had to move stuff to different areas for that reason. There just wasn't enough room to put everything in level 4, and so we'd have to temporarily store it in one area or other, or one of the offline labs, until it was basically ready. We had the space. So that's why I wanted to show this, just to show you it got real busy. And this is the mid-1990s, 94, when this was happening.
Good stuff. We're learning so much from Mikey Haddad here. We're going to see a couple more pictures here in the ONC. There's a great shot of the whole cavernous building there. And then Mikey's going to tell us about something that's been done at Kennedy Space Center only one time.
Yep.
The shenanigans that these engineers come up with.
Yeah, that's something I could talk about a little bit. But this is basically, again, the operations and checkout building. Now, this is on the west end. looking east. What the picture before is on the very far end of the building. That was the one we just saw. This is on the west end. You can see it's pretty full. And again, that's the antenna package that's in the site stand. It's basically, site was basically a dry run before actually going into the shuttle. This is the last stand, last kind of tests we did before we actually going into the orbiter. And so this stand was an emulator of the orbiter. So we try to wring all the problems out here before we got to the shuttle. So there wasn't any big problems once we actually got into the real shuttle.
And that's the canister it's in that's actually taken out to the pad on a vehicle vertically, right?
Well, the canister would come in, we either go horizontal or vertical. Yeah.
Okay.
Now for Space Lab, most of those went in horizontal. So we'd go from here to this building horizontally to the orbiter processing facility and go into the shuttles horizontal. For Space Station, it was just the opposite. Space Station, we go vertical and go in at the launch pad. So we had the capability to go horizontal or vertical.
Okay.
Yeah.
That's a great picture there. Love that. Brings back some memories to you space workers, I'm sure, out there.
Okay. This is the antenna inside the orbiter. Kind of the back of the orbiter is to the left. The front is to the front. You got kind of the platforms where it's kind of gray. There are access platforms that are actually over the shuttle doors, and that gained us access to that. One of the things I wanted to mention here, this is again from Riley Duran, who basically worked this mission. He's saying for STS-59, he said, big complex payload, but lots of fun, toughest problems tracking down and correcting the high rate data problems in the orbiter. So we tried to do all this tests. When we got in the orbiter, we found the problem. Okay, this is flight hardware against flight hardware. So this is what's flying. There's a problem. What do we do? And so he said it had to remove and repair all three of the payload high date recorders, which are in the orbiter. I remember we had to grab a moving van and forklifts to rush equipment racks over to the OPF where this was, in the middle of a thunderstorm, to help troubleshoot the problem.
Wow.
So again, that's why we went from level 4 to experiment integration, because our job went all the way through the Space Center. So now we're taking the racks that we tested in the ONC, we're having to haul them out to the OPF to test them with the orbiter to find, hey, what's going on there? Why isn't something working? And we found it was actually an orbiter problem that they were able to fix. So that's what I wanted to talk about.
You said the high data recorders. Have you seen our shuttle, our workers gallery, and the data recorders we have in there? Is that what we're talking about?
I think it's similar to what you've got, yeah.
Okay, we got it's black, and we call it the black box of the orbiters in there, and so
I just wanted to bring that up. It kind of, again, it gets from Riley, who was he was one of the main engineers. He was basically the lead mechanical engineer.
We were looking at one of the results of this amazing structure here. What it did in orbit right there was bring back pictures like this, or images, data that was created for like that. You said this is
this is actually an image taken by STS-68 of a volcano, and again, the colors all mean something. And the idea is
that erupted that day.
That erupted the day of the launch of STS-68, and when they went over, they imaged it with the radar system. I can't tell exactly what all those colors mean, but the colors, each color means something. Well, if you look at kind of where my head is there, that's kind of the main volcano. If you can see green streaks, that green streaks is the lava that was imaged coming out of the volcano by the the antennas.
Wow, yeah,
so each color means something on this. That's the thing that was so unique about this radar systems is you can basically, the whole idea of radar is you can image through clouds, through rainstorms. So it didn't matter what was going on, you could image the Earth. That was a big advantage of having radar. And then other advantages too. Again, I don't want to go into too much detail because I don't want to say something that's wrong, but the idea is that there was so much that this was able to determine from not only the surface but from the atmosphere. Like the MAPS experiment was looking for carbon monoxide, for example. There's so much that was learned and so much information. The best thing is just go out to the sites, the STS-59 and STS-68 sites, and read about what was just amazing. Again, this was precursor to a lot of the radar imaging we use today. That was just this started it all off.
Right.
I mean, this
satellites have been set up with similar things now, but
just amazing work.
There were discoveries made of well, let's show one discovery here.
Okay, this is actually a picture of Washington D.C. You can see it's not very colorful, so there's not much difference in this picture compared to the previous one, where there's a lot of different terrain, a lot of different things to image. The colors here are kind of blonde, and that's because it's basically it's a picture of a city more than a volcano or whatever. So I just wanted to kind of show the
certain amount of data there, but this is also penetrates the ground as we see in this image.
Okay, what this is actually in the Sahara Desert. This is under the sand. This was an image they didn't know that was even there. It's an ancient riverbed. Let me make sure I get this right here. That it was it was an ancient riverbed, invisible to the human eye. It was beneath the deep, dry sand. So this is something nobody even knew was there.
Wow. I understand they discovered some cities even.
Yeah, I think
under the sand and so forth, the Sahara.
So it's just amazing because this was ground penetrating radar as well. And this is what one of the images they got, which is just amazing.
Now we're going to get to some fun stuff.
Now, this is the real unique stuff, and that's Riley Dern on the right when he was younger, of course, back in '94. He's being interviewed by the news crew. Now, what's going on here? One of the things about radar, and the things they used to calibrate with, was called corner reflectors. And think of it: you take a cube and you cut off a corner of it. Okay, what the corner reflector does for you, and when you're imaging, is whatever angle the radar signal comes in, the corner reflector reflects it directly back at 180 degrees. Basically, so you get a huge, nice, strong signal, and you get a very bright signal. Okay.
So here we go.
Okay, so this is what we did. Is so the idea is these corner reflectors would basically be like little dots. Okay, well, if you set up corner reflectors in a pattern, you can image stuff from space. Okay, well, this is our team at Kennedy Space Center, putting a bunch of basically 30 corner reflectors, and I want to show this one here.
Right in the orange shirt.
That's me on the right, and kind of what we're doing here. You see the corner reflector is basically regular construction material that were put out. Now that one, go back real quick. I wanted to point out this one. You could see it's almost in a ditch.
Yeah.
Okay, so we had to line these things, basically keep them horizontal, and we had to point them in the right direction depending on where the shuttle's flying over. And this one specifically was near a ditch.
You're trying to signal the shuttle with these, with the reflection of this space radar lab.
Yeah, basically we want to set these up in a pattern so when the shuttle flies over Kennedy Space Center, it images these corner reflectors. Okay, there you can see basically how one of them is finally set up over by the NASA thing. Okay, now one thing before you go to the next one.
Right.
Okay,
we're here.
We're here. Okay, the next one, yeah, show the next one. That's our team. That's Riley in the middle. And you can see how big these corner reflectors are. They're about 4 feet. And that's a group of us that put all these corner reflectors together. We laid them out in front of the Operations and Checkout building and NASA headquarters building. Basically, that's what you see behind you there. We laid them out in a certain pattern. Okay. Well, before you change to the next slide, okay, what would be the pattern we want to put out there that whenever people would see this image, they know exactly where this image was from?
Take me with you.
Okay.
Maybe.
Okay. So what did we do?
But you want to brand it.
Show the next image. We went ahead and we spelled out the letters K or C in corner reflectors.
Inside the white
square there. That's basically, we laid the corner reflectors.
KSC, that's from 200 miles high.
200 miles high. What was neat about this was, of course, Riley was electrical. We had Louis Montezuma, who was our alignment specialist, he's in the surveying. He basically did alignment for Astro. He basically set up this pattern for us, told us where to put the corner reflectors. So it would look right. It would be, the letters would be the same, and the spacing would be right. And so this is basically what we imaged, only time ever at Kennedy Space Center. It was planned fly over Kennedy, and so the images, and this is the reflection they got back from those corner reflectors, was so bright that it was able to use it as little dots to spell out Kennedy Space Center, KSC. So that was a really unique thing we did. And again, Riley, he says one day, how did this all come about? He says, well, they were doing testing, long days testing. Sometime you just start talking about stuff. And he says, well, I know that they're going to be flying over Kennedy Space Center. Wouldn't it be cool to put one of these corner reflectors or a series of corner reflectors up at Kennedy in some kind of pattern? Okay, that'd be fine. And so he got the team together, and this is what we came up with, was the KSC letters. So, of course, now when you see this image, you know where it's an image of. It's Kennedy Space Center.
So I imagine that was done a little serendipitously.
Oh, no.
Kennedy Center.
Oh, no. Everybody knew about it. Yeah, we had approval and to lay all the stuff out. Yeah. Yep. It was all approved, and everybody.
And you get an idea of the radar, how that is the ONC building right there in front of it.
In front of it, yeah.
So you all that work out there, Marty, you know exactly where that's at, and you got the vegetation, you got some other different buildings reflecting there.
Yeah, north is actually down. I spun it around so you can see KSC. North is actually facing down in this image, but.
Gary Gerald up in Georgia, he probably appreciates that. It looks like a crop field there. Robert Law's up in Dundee, Scotland. We got Razor watching. Is that one of your Razor?
Mm.
Bill Whiting. Thank you, Bill, for watching. Space Monkeys there. Carlton Bailey. Cynthia Rossi, the Astronaut Files, and Doug Forrest. Thank you for all watching today. Hope you enjoy this episode of Stay Curious with Mikey Haddad. Mikey, we got
one more image. This is actually a corner reflector and a crater in the Sahara Desert. And it's to show kind of the professional one and kind of what it looked like compared to ours. So ours is pretty close to the professional ones. But they use these for calibration because you know the size of it. And you know the image, the radar image going down and coming back. It was a good way to calibrate the radar and stuff. And so
absolutely. So NASA would put these purposely around the world.
Yes.
To calibrate things in there. Fascinating. I'm going to read more about the Space Radar Lab. 2 great missions of the shuttle era, 68 and 59. And great behind the scenes of some of the paperwork and things that sometimes, like we saw there, they had a little anomaly that wasn't going to cause any problems. Mikey, thanks a lot. I was looking here and seeing if I had any notes here. I found it interesting that the astronauts do ask for your help once up there.
Well, in fact, a lot of them almost demand it. That says, we want those people to be sitting on console during the flight because they were there when we were testing this.
Cool.
So it's almost they handpick. Okay, this person was there, that person. I want those 3 or 4 engineers to be on console because I worked with them for 8 months and I trust what they say and what they do. So it was for those guys that did those missions. Kudos to them because they were super people. They still are super people.
Well, great insight, Mikey. Thank you so much for another great Stay Curious program. He'll be with us in Rocktober to talk about something about the 12 shuttles that we have in Rocktober. And tomorrow on Stay Curious, we're going to do some little bit of astronomy. We're going to talk about the auction, show you some more items that you could own. Like a flag that was on the lunar module on the surface of the moon. How'd you like to own a piece there? We have a credit card sized plastic card that's got a piece of rope that was on the moon on Apollo 14. Sweet. Yeah, you need that. You can have that for about $1,500, Mikey. Just bid till it hurts.
There you go.
On Friday, we've got Dr. Gary Studi, is the world expert on growing food in space. Okay. He's been growing radishes, a little bit of lettuce up on the space station. He said after 20 years, they finally let him eat a bite of it there. Mikey, we're going to enjoy Dr. Gary Studi. He's a good friend of the museum, personal friend of mine. You're going to enjoy what is on the cutting edge about, if we're going to Mars, we got to feed some people. Well, and they just can't be eating, TV dinners all the way. You need to have some more nourishment than
that. It's critical that they get this to work like it's working,
so we thank you for all that you do here, buddy.
You're welcome.
Marty,
it was a lot of fun
great show today. We did have a little anomaly like I was talking about. We had an anomaly. We couldn't load your pictures, so we did a workaround, and that's like what you talked about doing. We had to, that's why you check this stuff out. One day you come back to it, you turn it off. Next day it's a completely, what's wrong with this stuff here? So you really gave us a good insight there. So we hope that everyone can join us the rest of the week. Friday will be our 900th episode of Stay Curious. How about that?
Wow! Congratulations!
So, thank you.
900.
We'll roll out the carpet and have some dancing and clowns and stuff like that for our 1,000th one there. I'm not afraid of clowns, so bring them all in here. So, all right. Well, until tomorrow, when we're going to talk about our 26th Space Memorabilia auction, some space history, and Friday, we're going to have Dr. Gary Studi here. I hope you enjoy it and watch those programs with me, Mark Marquette. Until then, we'll see you in our museum, I hope, to bridge the space between us.